Hi everyone, this is going to be a video on combustion reactions. And so combustion reactions are the reactions behind all sorts of fires, all sorts of explosions, all sorts of really energetic reactions, right? And so the general form for a combustion reaction is you have some sort of carbon source, some sort of hydrocarbon, plus oxygen, gas, and it reacts, and the products of a combustion reaction, in particular a complete combustion reaction, are always the same. You're always going to get carbon dioxide and water. Okay. And generally, what's going to happen is combustion reactions produce a lot of heat. Okay, a lot of heat. All right, and so that's the general form for a combustion reaction. Now, over here, this hydrocarbon, right? Well, there's a whole class of different fuel sources, okay? And so for a combustion reaction, we generally refer to this as fuel, okay? So for example, we can have just carbon, we can have hydrocarbons, we could have these carbohydrates, right? CHXYOZ. We can have, proteins, OZN, W, right? Lots and lots of different kinds of fuel sources. And so we can burn a lot of different stuff. The main point here is that we are reacting it with oxygen, forming carbon dioxide, water, and a whole bunch of heat. Okay. So for example, if we had C6H6, it's a liquid, that's benzene, and we react it with oxygen, this is some sort of hydrocarbon, some sort of fuel source, some sort of oxygen, right? So this is good chance that this is a combustion reaction. The products of a combustion reaction are always the same. They're always carbon dioxide and water. The hard part about a combustion reaction is balancing. So there are 6 carbons on this side, so all of the carbons on the hydrocarbon actually end up in the carbon dioxide. So that serves as a pretty useful way of trying to figure out how many carbons there are. All of the hydrogens end up on the water. So there are 6 hydrogens here. We'll have to put a 3 here to balance that out. And finally, we need to balance the oxygens. If we count, there are 6 times 2, or 12 here, 3 times 1, or 3 here. That gives you 15 oxygens. Okay? We have 2 oxygens over here, and so you'll notice that 15 and 2 don't really go into each other evenly, but we can force it to go in, right? There's a very useful trick. We can actually just put a fraction here. Right? We can put a fraction there. So 15 halves. Normally, we don't write chemical reactions with fractions, though. So what we do is we're going to multiply everything by 2. So this becomes 2 C6H6 plus 15 halves times 2 is 15 oxygens. Okay, 12 CO2 gas plus 6 H2O gas. And there's the balanced reaction, right? And so when you have an odd number here, you just, divide it by 2 and you put it there. That fraction, a lot of times, like informally, you'll just leave the fraction like that, but it's more proper to write the chemical reaction like so. Okay. All right, take care, everyone.